Good day to all. Today we are going to see about the transformers and the basics and the types of that transformers. First of all, we will see the overview of that transformer. What is that need of transformer? Then introduction, then history, principle and the construction and working. Then the types of transformer applications. We will see all here. First of all, what is the need of transformer? See, in most cases, appliances are manufactured to work under some specific voltage. The transformers are used to adjust the voltage to a proper level. Then the transformers are basic components for the transmission of the electricity. Then the transformers is used to increase the voltage at the power generating station, which is a step up, and used to decrease the voltage step down for the household purposes. We will deeply about this step up and step down transformers. By increasing the voltage, the loss of electricity in a transmission purpose is minimized over here. Then this is the introduction of the transformer. See, first of all, transformer is a static device. That is a stationary device. That is a static device. And here in this transformer, the electrical energy from one part of the electrical or electronic circuit to the other part of the circuit without changing the frequency. Otherwise, we will simply say that the electrical energy changes from one form to another without changing the frequency. It works on the Michael Faraday law of electromagnetic mutual induction. See, this is the pictorial representation where we are used for that transformer. If it is, see here, this generating station, then there will have one step of transformer. Then this is the transmission line. In between the transmission line also we have a transmission for step up, as well as in the substation we will have a step down transformers. Then they will go for industries as well as the household purposes. The history of the transformer. So the first transformer was developed by Otto Blaty in the year of 1885. Further, in 1885, William Stanley makes the transformer more practical due to some design changes and developed a three-phase transformers. The design of William Stanley was the first commercially used in the USA in 1886. What is the principle of this transformer? See here, its working principle is it works on the principle of electromagnetic induction. This is the working principle of that transformer. What is that electromagnetic induction? When the current is provided to the primary winding, it behaves as a electromagnetic. Due to this, EMF is induced in the secondary winding. As it comes in the area having magnetic field lines due to the primary winding. The formula for that auto transformer is here is Vs equal to Ns into d by dt, where Vs equal to secondary winding voltage and Ns is to secondary winding voltage. This Vs is secondary winding voltage and Ns equal to secondary winding turns. See here, this is the coil 1, this is the coil 2. If you are giving the supply to this coil, then the EMF will induce over here. This is called the electromagnetic induction, mutual induction. The types of these transformers and the parts of the transformer we will see one by one here. First one is laminated core and winding, tank, isolation, breather. These are the parts of that transformer. First one, cores are designed not to have a current in it, but still is there leakage current or the eddy current present in it. So to minimize the current, the cores are laminated. Then winding made up of this winding made up of copper or aluminum coated with very thin layer of insulation. The tank. The main function of that conservator tank of transformer is to provide adequate space for expansion of oil inside the transformer. It is usually cylindrical or cubical. It is provided by using synthetic oil between core and tank. When the temperature changes occurs in transformer insulating oil, the oil expands or contracts and there an exchange of air occurs when the transformer is fully loaded. When transformer gets cooled, the oil level goes down and air gets absorbed within. See what are the types of transformer. The types of transformer with the basis of construction, we will have a core type transformer, shell type transformer, spiral core transformer. With the basis of winding, we'll have a step up transformer, step down transformer, isolation transformer. With the basis of coolant material, we'll have a oil filled self cooling transformer, oil filled water cooling transformer, and air blast transformer. Now, this is the basic construction of transformer. Here, this is the core type, and here this is a cell type. See here in core type transformer, it cores has a two limbs. The winding are wounded on two limbs of the core material. Then cell type transformer, it core has a three limbs. You can see here the three limbs, and both windings are wounded on a central limb, one over each other over here. The spiral core transformer. The core constructed is similar to wheels of spokes. The windings are wounded, the spokes like a structure. Then you can see what is that step up transformer and step down transformer and isolation transformer. You will see the diagram here. This is the primary coil and this winding is called as primary winding, and this is the secondary coil and this winding is a secondary winding. See, if you are giving the supply to this primary winding, then the current will flow through this coil. Because of this coil, the magnetic flux will induce over here. In this magnetic flux induced over here, then the EMF will generate. This EMF will have a nearer to this coil also. This is the process of transformers will transfers the voltage from this circuit to this circuit. Now we will see about the step up transformer. The number of windings on a primary side is lesser than the secondary side is called step up transformer. The thing is the voltage must be high in the secondary winding. In the primary winding is lesser than the secondary winding. See, this NP is number of turns in primary winding. This secondary is number of turns in secondary winding. Now step down transformer. Here the number of windings on the primary side are more than the number of windings on the secondary side. This one is lesser than the secondary winding, which is called step up transformer. Here this one is greater than the secondary winding. You can see the coil over here. Here the coils are more, here there are less. So it is lesser than this one. The secondary coil lesser than the primary coil. Now the primary coil is have a more number. This is called a step down transformer. See, in the power generation we will use this step up transformer, but nearer to our home itself we will use this step down transformer. Then what is that isolation transformer? The number of windings on the primary side are equal to number of windings on the secondary side. NP is equal to NS. If it is NP and NS are equal, then that is called isolation transformer. Thank you.